Here we have a 2D support reactions problem. So we have this bar that is supported at point A by a hinge and at point B by a roller. And on this bar we have a distributed load and we have a concentrated force. And now we are asked to first draw a free body diagram and then to calculate the three support reactions. So let's jump right in, get our free body diagram. But before we can get that, we need to take our distributed load and turn it into a concentrated force. So we can say R. Remember, that's just the area under the curve, under the loading curve here. So it's a rectangle. We have 10 meters is the length of our rectangle, and the height is 400 Newton per meter. And that gives us, of course, 4,000 Newton, or we can just do 4 kilonewton. Now, where does it act? Well, we know it's a rectangle, so it's going to be halfway there. So we can say X bar is equal to 1/2 times 10 meters equal to 5 meters. All right, so we have our concentrated force, so we can draw our free body diagram. Let's squeeze that in here. So this will be our bar. We have some support reactions. So we have the hinge. If we take the hinge away, remember that gives us a force in the X and the Y direction. Right? So if I have the hinge there, I can't move my bar up and down or left or right. That's why I get those two reactions. So we'll do AY and AX. Again, the direction is entirely up to you. I usually have it pointing towards the bar, but again, it's up to you. On the other side, on the point B, we have a roller. Remember, the roller only takes a compressive force, right? So it doesn't stop the bar from going left or right or going up, just keeps it from going down. So in this case, we will put B here. We don't have to put BY because there's only one B. And then we have our two forces. We have our force right here. This is R equal to 4 kilonewton. We know this distance here is, we just calculated 5 meters. And then we have our other force somewhere over here. That is 2 kilonewton. And then we should add ourselves a coordinate system, X and Y. And with that, we are done with our free body diagram. We have all the distances from up there. So let's go and calculate the three support reactions. All right, we have AX, AY, and B. Those are the three that we're looking for. Now I could write out all our equations and see where we land, but let's try and be a little smarter about this. So let's go and see if we have any equations that only contain one unknown. Right, so if we start with F is equal to Fx is equal to 0, how many forces do we have acting in the X direction? Well, we really only have AX. Right? So all the other 4 forces are all only acting in the Y direction. So that's only one unknown. So we can say F sum of forces in the X direction equal to 0. And that is equal to, well, we have AX. It's going in the positive X direction, so positive. So we know that AX is equal to 0. Makes sense, there's no load going in the X direction. Now if we look at AY, right, then we have all our remaining forces would be going in there, and both AY and B are unknowns, so that really doesn't help us anywhere. Now if we've used our two force equations, then we're left with momentum equations. So if we think about, for instance, doing the moment around, let's put an A here so we remember, and a B there. Right? If we, for instance, do the moment around A, right, then AY doesn't have a moment arm, and neither has a AX, but we already know X is 0, so it doesn't really matter. So the only unknown that has a moment arm is going to be B. So we can directly solve for B out of that. So let's do that. We say sum of moment around A equal to 0. And what do we get? Well, we get R, distance of 5 meters, and it is turning clockwise. So minus r times 5 meters. Then the 2 kilonewton over here also goes clockwise. And what's the distance there? Let's scroll up a little bit. So that was 15 meters if we look towards A. And then B is turning counterclockwise, so positive. That's good because the other two are negative. And it has a distance of 20 meters. All right, so now we have one equation with one unknown, and we can solve for it. So we can say B times 20 meters. R was 4 kilonewton, right? So it'd be 4 kilonewton times 5 meters plus 2 kilonewton times 15. We're listing in meters there. Times 15 meters. That would be 20. That would be 50. 50 kilonewton times meter. That means B is equal to 50 kilonewton meter divided by 20 meters equal to 2.5 kilonewton. So that would be our second support reaction. Now it is positive, so it means that B is pointing upward as we assumed, right? If we're negative, pointing downward. Now in our case, this was a roller, so it has to be pointing upward. So if we get a negative number here, we need to go back and check what went wrong. So now we have B and AX. Now we could take Fy as sum of forces in the y direction equal to 0, because AY would be the only unknown. But again, as we talked about in class, I prefer not to do that because it will depend on B. And if I did a mistake with B, then that will translate over to A. So what we can do instead is we can do a moment around B, and then the only unknown is going to be AY. So let's do that. Sum of moment in around B equal to 0. What do we get there? We get AY, so AX, 0, but also doesn't have a moment arm because the line of action goes through B. But AY is turning clockwise, so it'll be minus AY. That was the full length of the bar, so 20 meters. Then we have the R, that is going counterclockwise, and it'll be 15 meters. That'd be R times 15 meters. And then our 2 kilonewton also counterclockwise, 2 kilonewton, and the distance should be 5 meters. Yeah. That means I'm sorry. That means AY times 20 meters is equal to R was 4 kilonewton times 15 meters plus 2 kilonewton times 5 meters. And that together is 60 plus 10 is 70 kilonewton meters. So that means AY is equal to 70 kilonewton meters divided by 20 meters, 3.5 kilonewton. AY comes out positive, which means that it's acting upward as we assumed it would. That makes sense too, because our other two, the loadings are all going downward, and we don't have any kind of cantilever or something that would reverse it. So it's good that they're pointing upward. Now we can also do a little test here, because we didn't use Fy to calculate any of the forces, so we can do a quick check if Fy is equal to forces in the y direction equal to 0. So we can say AY was 3.5 upward, B was 2.5 upwards, so that would be 6 in total. And we have R is equal to 4 kilonewton, and the other force was 2 kilonewton acting downward, so they will cancel each other out. So our result seems to be correct. So with that, we've gone through this little 2D support reaction problem, and we solved for the 3 reactions. We had the 2 reactions at A and the reaction at B.